everyone. Today we're going to take a look at some different types of exponent laws. So as an extension of what we did a couple of lessons ago, we want to take a look at rational exponents. Now remember rational numbers. So our set of rational numbers looked like a over b, where a and b are integers, so no fractions or decimals within the fraction, and where b was not equal to 0. So any number that could be written as a fraction is a rational number as long as it doesn't have any decimals or fractions within it. B cannot be equal to 0 because otherwise it would be undefined and we couldn't calculate it. So what we're going to be looking at is where we have fractions as our exponents. So keying into your calculator 4 to the power of 1/2. We can key in 4 to the power of 0.5, but it gets a little more difficult when we're talking about things that don't round evenly. So what we're going to do is key into our calculator 4, then your exponent button, and in brackets. So we're going to make sure that that 1/2 is in brackets. So 4 exponent button bracket 1 divided by 2 equals. And you should find that you're getting an answer of 2. If we do the same thing, 9 exponent bracket 1 divided by 2, we get 3. Well, taking a look at these two, we notice that 2 is the square root of 4. 3 is the square root of 9. Taking a look at 8 to the power of 1/3. So in your calculator, 8 exponent bracket 1 divided by 3, and we get an answer of 2. Well, again, thinking about the same kind of ideas we had in these first two, well, 2 is the cubed root of 8. Well, that makes us wonder, does that bottom number come around to be our root? So if we think about 16 to the power of 1/4, is the fourth root of 16? What is the fourth root of 16? 4 2's all multiplied together to give us 2. So checking this in our calculator, 16 to the power of bracket 1 divided by 4 and equals, and we do get a 2. So there is another way to write our exponents when they're fractions. We can write them as, if we have x to the power of 1/2 or x to the power of 1/n. So any fraction, 1/2, 1/3, 1/4, we know that we're going to bring the bottom of that fraction around. The x is under the radical, the base is under the radical, and we're going to root that x value. And we're going to, if the bottom is a 3, we're going to cube root it. If the bottom is a 5, we're going to fifth root it, etc. So, and don't worry about this, consider. We're going to talk about what if we have, let's say, 8 to the power of 2/3. What's going to happen there? Well, keying that into our calculator, what do we get? 8 to the power of bracket 2 divided by 3, we get 4. Well, looking at this, we know that we could take this 3 around to become the cubed root of 8. So we can write that as the cubed root of 8, but now we still have to have that 2 applied there. Well, the cubed root of 8 is 2, and we still have that squared outside there, which means that our answer is 4. So our next exponent law, still consisting of our rational exponents, if we have m over n, it simply means that we can rewrite this with the n as our root, and then we still have to the power of m. In the previous question, our top number on our fraction was 1, which explains why it doesn't change. To the power of 1 just means itself. So, for example number 1, if we want to write as a radical, we're simply going to take that bottom of our fraction from the exponent and make it the root. Our base goes under the radical. Notice that if that's a 2, a square root, we don't have to write anything on the radical. If it's anything but, then we need to write the number on the radical sign. So our base under our radical, bottom of our fraction comes around, and we are looking for the 4th root of 81, or 4 of what number give us 81. In this case, we don't have to evaluate, we were just asked to write it as a radical. Next one, again, 125 under the radical sign. The bottom of the fraction becomes the root, and we still have that 2 on top outside the brackets. For our next one, negative 125 comes under the radical, bottom of our fraction becomes the root, and we don't have to write our brackets with a 1 outside. We know that doesn't change anything. And just an aside, we can do this calculation because we can have 3 of a negative number that gives us a negative answer. If we have any squareds, fourths, sixths, anything on that is an even number, it's not possible. With odd ones, we can. Next one we want to write as an exponent. So we're going to do the opposite. So this 10 is going to come around to be the bottom of our fraction in our exponent. So 1024 to the power of 1 over 10. Under the radical is the base. We bring the 3 around to become the bottom of the fraction, and the 4 stays in the top of the fraction. For this one, we're going to have bottom, or under the radical, becomes our base. Our 2, remember if there's no number there, it's a 2, and we're going to have negative 1/2 as our exponent. For number 3, we want to evaluate. So we are going to, first of all, write it as a radical. So we're going to have the root of 49, which we know is 7. For our next one, we are going to have our 4 under a radical. It was a 2 on the bottom of the fraction, so we don't have to write that. And we have our 3 outside. So square root of 4 is 2, and now we're going to cube that. Means that we have an answer of 8. Next one, we are going to leave our negative outside our bracket, and the 2 is going to become the root of 100. So anytime we have a negative fraction, we're going to keep the negative with the number outside the brackets, because we can't do a negative root. So square root of 100 is 10, and 10 to the negative 1 means we're going to have 1 over 10 to the positive 1. Next one, we're going to have our cubed root of 8, and we have our negative 1 outside the brackets. Cubed root of 8 is 2, and now we want to take that 2 to the negative 1, flip it to the bottom, where it becomes 2 to the positive 1, and we don't have to write that exponent on there. Bottom of the fraction comes around to become the root. So we're looking 4 of what? Give us 16. And it's an even number, so we're going to use 2, 4, etc. So we can get an idea of what's under the radical, where we want to start. So we're going to start with 2. 2 times 2 is 4, 8, 16. So our 4th root of 16 is 2. and we still want to cube that, so our answer there is 8. So these questions, we want to make sure that we don't need to use a calculator, okay? And we want to show our steps, first of all, writing it as a radical and simplifying. Now, number 4, we do want to use our calculator because it's telling us accurate to 2 decimal places. And we're not going to be able to do a 2.3 as a radical, okay? So, putting into our calculators, 7 and our exponent button, and then 2.3 and equals, and we should get 87.85. Next one, in our calculator, we're first of all going to do 9 divided by 25, and we can equals, and then we're going to do our exponent, and in brackets 1 over 2. 1 divided by 2. So 9 divided by 25 equals exponent bracket 1 divided by 2, and we should get 0.6. Now that one we could do as an exact value. We could do our square root of 9 over 25, and we know that when we multiply fractions, we multiply tops, multiply bottoms. Going the other way, we're going to square root the top, square root the bottom. So our answer there would be 3/5, which is the same as 0.6. Next one, we have 3 over 2 to the power of 1/2. So we're going to, in our calculators, put, and actually this, we're going to change this, guys, to 1/4. This should be 1/4. So in our calculators, we're going to put in 3 over 2, which is just 1.5. So we can put it in as 1.5, exponent, bracket, 1 divided by 4, and equals. And we should get 1.11. Next one, we have 5 over 6 to the power of -3/4. We can simplify that as much as we want, but we notice that, again, tells us accurate to 2 decimal places. So we're going to put in there 5 divided by 6 equals, to get what our value is, to the exponent, bracket, -3 divided by 4, and equals, and we should get 1.15. Okay? So that's our rational exponents, how we can simplify that, and you have some questions.